In this problem, we have a column of argon is open at one end and closed at another end. The shortest length of such a column that will resonate at 200 Hertz tuning fork is 42.5 centimeters. Okay, we want to know what the speed of sound is in argon. So I take a look at this problem and I say that I have a gas-filled tube, and there's argon in here. Argon. Place in here, and we're going to have it resonate at a 200 Hertz tuning fork. And it's the shortest length that will do this, which means I know that I am at my fundamental frequency. So this length right here is 42.5 centimeters is equal to L. And I know that the frequency that I get out of this is going to be 200 Hertz. And this is actually for my lowest fundamental frequency. And I want to know what is my speed of sound. Well, the ultimate equation that I need to use is the frequency times the wavelength is going to give me my velocity. So I need my wavelength. And if I get my wavelength, I'm done. I have my frequency. I don't have lambda. If I get frequency, I multiply it by lambda, I'm okay. Well, I see over here that this tube right here, this length, is equal to a quarter of the wavelength. Right? I go from a node to an antinode, so I'm a quarter of the way through the cycle. I have to go node, antinode, node, the low antinode, and back up. So this is a quarter wavelength, which means 4 times L is going to be equal to my wavelength. So that means I just substitute in. I get 4L times the frequency is equal to my velocity, which when I plug in the numbers is 4 times 42.5 centimeters times 200 Hertz. 42.5 times 2 is going to be, so 5 is going to be equal to, actually, yeah, so 200 times 42.5 centimeters. Still get that 4 out in front. I have a 0, carry a 1, I'm going to have a 5, and I'm going to have an 8. So 85 centimeters times 100 Hertz still. So the centimeters and the 100 will cancel off when I convert to meters. So this is going to be equal to 85 times 4. So 4 times 85 is going to be 0, carry my 2. 4 times 8 is going to be 32. So 340 meters per second. So I come up with the speed of sound in this problem for argon is going to be 340 meters per second, which kind of an interesting number because this is the number I remember for the speed of sound in normal air. And air is composed mainly of nitrogen, diatomic nitrogen.